While factoring out a monomial from a polynomial may be the simplest factoring technique in all of algebra, perhaps the most broadly used factoring technique in algebra is that which permits you to factor a quadratic trinomial. So that's a polynomial whose highest exponent is 2 and which has 3 terms, such as the one we're looking at right here, into a product of a binomial times another binomial. In other words, to write this as a product of one polynomial with 2 terms times another polynomial with 2 terms. One of the reasons this is such a beneficial thing to do is something you'll appreciate in the next video, because to factor a quadratic trinomial gives us a way to solve an equation that has a quadratic trinomial in it for its variable. After all, that's the ultimate goal of learning how to factor, is it gives us perhaps the most powerful tool for solving an equation that involves a polynomial, because reversing the order of operations is not sufficient in general to solve a polynomial equation. So how can we factor this quadratic trinomial into a product of one binomial times another binomial? First, and this is going to be true in general of any expression we wish to factor, let's try and do the simplest factoring that we can do first, and look and see if when we break this apart into a product of one expression by another expression, whether there's an opportunity to first factor out the greatest common factor of these 3 terms. In this example, that answer is yes. Finding the greatest common factor of 5x squared, 10x, and 40. We first find the greatest common factor of the coefficients 5, 10, and 40, which is 5, and then multiply that coefficient by the smallest power of x that we see. And since the term with the smallest power of x is this term, which has no power of x in it at all, no power of x survives into our greatest common factor. But we do find that the 3 terms which make up our original polynomial have a 5 in common, and we should begin the process by factoring out that greatest common factor. So we'll first bring a 5 outside, and inside determine the leftovers by dividing each of the 3 original terms by 5. Dividing 5x squared by 5 gives me just x squared. Dividing 10x by 5 gives me 2x. And dividing 40 by 5 gives me 8. So we've first succeeded in factoring out the greatest common factor of these 3 terms. The expression that we're left with, x squared minus 2x minus 8, is still a quadratic trinomial. Quadratic because the largest exponent is 2, and a trinomial because it involves 3 separate terms which cannot be combined together because they're not like terms to one another. So we're going to need a new method if we want to factor that part of our expression, x squared minus 2x minus 8. The method that we're about to use works only when the coefficient of our highest order term, the x squared, is 1, which it is in this example. When that coefficient is 1, we can use a technique called the sum and product method to determine how to factor this quadratic into a product of one binomial times another binomial. The sum and product method works by searching for a pair of integers, whole numbers, whether they're positive or negative, that has 2 properties. The first property is that the product of these 2 numbers has to give us the constant term of our quadratic trinomial. So our numbers have to multiply together in this example to give minus 8. But that same pair of numbers must also add together to give us the coefficient of the term which has x to the power 1 in our quadratic trinomial. So in this example, that same pair of numbers which we choose that multiplies together to give us negative 8 must also add together to give us negative 2. Typically, solving this sum and product question begins by thinking up pairs of whole numbers which multiply together to give the desired product. for -8. I might think of pairs like -8 times 1, -4 times 2, -2 times 4, or -1 times 8. Of those pairs, the pair which also adds together to give us -2 is the pair -4 and +2. We can check that when those two numbers are multiplied together, their product is +8. And when that same pair of numbers is added together, their sum is -2. So this is the pair that we're looking for. What do we do with those numbers? Well, those numbers become the constant terms in our pair of binomials, which will multiply together to give us our trinomial. So -4 and +2 become the second terms in our binomials, of which the first term will be x. And our complete factorization of this polynomial, therefore, includes the product of x minus 4 with x minus 2. This product gives us this quadratic trinomial back, x squared minus 2x minus 8. But don't forget that it also must include the greatest common factor that we factored out in the beginning, which is our 5. So to factor a quadratic trinomial, a polynomial whose highest exponent is 2 and which has 3 terms in it, first, and this is true in any factoring problem, look for an opportunity to identify and factor out a greatest common factor. In this example, we were able to factor out a 5 from all of our terms in the very beginning to give us then a simpler quadratic trinomial that we could focus on in the next step. Because that quadratic trinomial had a coefficient of 1 on the x squared, we can use the sum and product method to look for a pair of numbers which multiply together to give us the constant term in our polynomial, here -8, and that same pair must also add together to give us the linear coefficient, the coefficient of x to the power 1, which in this example was -2. Finding that pair of numbers, if it exists, and it will not always exist, in which case this factoring method will not work, but when that pair of numbers exists, each of those numbers becomes the second term in a binomial whose first term is x, that allows us to factor this trinomial into the product of x minus 4 times x plus 2, and then remembering the 5 from our greatest common factor completes the factorization process. Please note that as in any factoring problem, you can always check your answer at the end to verify that it's correct. To check your answer in a factoring problem, simply re-multiply your answer back out and determine whether or not that re-multiplied expression gives you the original thing that you were looking for. Re-multiplying x minus 4 by x plus 2 will require us to use the technique known as FOIL, distributing multiplication over addition and multiplying the first pair of terms, the outer pair of terms, the inner pair of terms, and the latter pair of terms. The first pair of terms will give us an x times x, which is x squared. The outer pair of terms will give us plus 2x. The inner pair of terms will give us minus 4x. And the latter pair of terms will give us -4 times 2, which is -8. Combining the like terms in the middle, plus 2x minus 4x, gives us minus 2x. And at this stage, we notice that foiling this product back out gives us the correct quadratic trinomial from which we got that factorization, x squared minus 2x minus 8. Which means, as we hope, that if we then also multiply that trinomial by 5, we'll end up with 5 times x squared minus 5 times 2x minus 5 times 8, which is exactly 5x squared minus 10x minus 40, our original polynomial. So any factorization problem can be checked by multiplying your answer back out carefully. If you arrive back where you started, then your answer has no choice but to be correct.